Hey everybody, and welcome to a homework help video. If you are new to watching homework help videos with me, I'm Mr. Parsons, and what I do is I'm gonna go into the homework assignments, the same homework assignments you should have for yourself, and I'm gonna go through them. I'm gonna do each of the questions, the whole thing. I'll show you hopefully a couple methods that can help you answer these questions, because I do realize that when you like learn a lesson and you learn how to do the types of problems you see on the lesson, the homework questions aren't always exactly the same. They have the same kind of like thinking involved, but you don't always get exactly the same type of problem. So I'm going to show you how to answer the types of problems that you've been assigned. They should be very similar to what you would have experienced by watching the lesson, but also yeah, I'm going to show you maybe some alternate methods to answer these as well, and help it get done fast and efficiently, and help you master this concept of graphing quadratic functions. Now we have two assignments here. Today I'm going to do part one. Well, not today. I'm going to do part two today also, but I'm going to do part one in this video, and then I'll have a separate video for part two. So let's get this thing going. So part one has 8 questions here, and we're in. So the first question I have is, graph the function h of x equals 3x squared. So to graph the function, we're going to plot the points with -2, -1, 0, 1, and 2. Now, the appropriate method for doing this is you have to physically plug in those numbers for this. On this first problem here, I'm going to show you how to do that the legit way, and then I'm going to show you a little bit of an easier way. Spoiler alert! Now you're fast forwarding the video. Wait, if you're hearing that, you didn't fast forward the video. Good job, you. All right, so I've got my handy dandy notepad here, so I'm gonna be writing by hand on the screen here. All right, so the function is 3x squared. So to set up a table for this, like the way they would probably want you to do it, is you want to set up a 3-part table. So the inputs go in on the left side here. 2, 0, 1, and 2. That's what they told you they want to plug in. They don't always tell you that, but this is what they told us here. So these are the x values, and this is the h of x value. To be legit, I really should have put h of x equals that in the middle. Whatever, it's fine. So I'm going to do 3 times -2 squared, and 3 times -1 squared, and 3 times 0 squared. I think you're getting the gist of where I'm going. I'm replacing the x each time with the value that's supposed to be plugged in for x. Now you can use a calculator, whatever. I'm really gonna skip the process here. I hope you'll understand that this makes 12, this makes 3, this makes 0, this makes 3, and this makes 12. Let me write those outputs again on the far side. Yes, it'll look symmetrical. That's not always the case, but in this case, that's what's happening. So if I'm graphing this, I will say, okay, I plugged in -2 and I got out 12. So I go left 2 and up 12. I plugged in -1 and I got out 3, so -1, 3. I plugged in 0 and I got out 0. And then I plugged in 1 and I got out 3, and I plugged in 2 and I got out 12. So that's it. I plug the 5 things in, I see what I get out. Then you kind of make an ordered pair. I guess I could add this on to the end here, that once you have the beginning and end stuff, you're technically graphing this point. -2, 12, -1, 3, 0, 0, 1, 3, 2, 12. And then you click this little button to make a parabola. That's what Alex will want you to do at least. And voila, it's graphed. Check. Hooray! 1 down, 7 to go. Okay, another problem. This one says graph g of x equals 2x squared minus 1. And the difference between this and the last one is it has a -1 at the end. Ooh, so difficult. Actually, not really. It just means the graph shifted a little bit compared to the other one. I'll do it the same way. So here, I'll do it 100% setting up. So we have x. We have g of x equals 2x squared minus 1. And then we have our output column. I guess that's kind of a technically correct way to write it. If you're watching the lesson video made by Mr. Steiger, I think he did it this way. I watched it, sort of. I skimmed it. I want to make sure I had questions on the homework that were related to what you need to do. But I can't be 100% accurate. Unless I were to make this right after watching his videos, I guess that'd be fine. Hey, notice I'm doing the same thing. I'm putting in each of the numbers, and I'm also including -1 at the end of each one. And this is simple calculator stuff here. I mean, you should use a calculator, I'd say. You get 8. -2 squared is... Oh, no. Pause that. You don't get 8. You get 7. -2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. Okay, then I get -1 squared, which is 1. Times 2 is 2. 2 minus 1 is 1. This is 0 squared, which is 0. Times 2 is 0. -1 makes -1. And then here we get 2 minus 1, which is 1 again, and 8 minus 1, which is 7 again. Again, symmetrical. So let me write those values again. We get 7, 1, -1, 1, 7. And if you prefer to write ordered pairs to show what you're about to graph, I plugged in the x values and I got out the y values. So let me put them as a pair so we know how to graph. 2, 7. Perfect. All right, so we're going to put a point at -2, 7, -1, 1, 0, -1, 1, 1, 2, 7. Okay, now I did all of these by plugging stuff into the table there. When we get to some later problems, there's going to be some more here. I'm going to show you a different way to do it. I hope you'll enjoy that way. Before we get to those problems, though, there's a few questions here about analyzing a graph. Now, on this problem 3, and there'll be another one on 7, there is going to be a picture here showing you a graph, and you have to decide on some answers on some stuff. So, does the parabola open upward or downward? So, in this case, you'll notice the two lines at the ends of it are flying to the top. That's what it means by upward or downward. A downward, let me draw a picture. A downward one would look like this. That's downward. Okay. Now, I don't believe that was on the lesson, but I'm just telling you here. So this goes upward. It should be intuitive, I would think. Okay, find the equation of the axis of symmetry. That was from the lesson, but the lesson showed you this. ax squared bx and c. You saw problems in this format, and what you were told to do is that the axis of symmetry is x equals -b over 2a. The problem is we didn't get an equation to use here. So it's a little different from what we saw on our lesson. But if you were given an equation and not a picture, 100% you should do the opposite of the b value over twice the a value, and that'd be a done deal, right? Here you can see the axis of symmetry by checking where the graph turns around. So notice at the very bottom here, the graph has a vertex, as in the bottommost point, that's left 2 and down 4. Now that answers 2 questions for me right now, okay? So let me take this, delete that. So I'm going to write this over here. So for my problem, the vertex is at -2, -4. That's the lowest point on the graph. And that means, for mine, the axis of symmetry, I'm just going to call it AOS, is at, it's not really an at, it has an equation of x equals -2. It's that simple. Well, wait, I didn't explain what's that simple. The vertex, whatever the x value is, that's what the axis of symmetry is. So one way to find the vertex and the axis of symmetry is by using a formula that you would have seen from the lesson, which is really great if you have an equation. But also at the same time, if you graph it and can identify the vertex from the graph, the axis of symmetry can be found by just taking the x value and saying that's what it is. So just so you know, it's easy on these problems, the axis of symmetry, -2 and all that, but what if it was a fraction? It would be very hard to see that on a graph. So it's very important to know that you would want to do -b over twice the a value. But for this problem, we're going to write x equals -2. Hey, by the way, when you're doing your homework, it's very important you write x equals -2. If you just write -2, you will get it wrong. So please write x equals -2. It's always x. Why is it always x? Because x equals -2 is a vertical up and down line. So imagine, if you will, a dotted line cutting this in half, which I believe you saw on your lesson. So that's why we're saying this is the equation of the axis of symmetry. This, if I were to graph this line, it would make a vertical line cutting it in half. All right, for both the x and y intercepts, make sure to do the following. So we're going to write some intercepts here. Now, it's nice in graph, so we can just look at the graph and identify it. We have an x-intercept at 2, another x-intercept at -6. It says if there's more than one, separate them with commas. So I'll write -6 and 2. Please don't put parentheses around it. You're not writing an ordered pair. You're just saying the x-intercepts are at -6 and +2. You do not need to write them in a specific order. I could have written 2, -6, but I like to go least to greatest. I guess it doesn't really matter, though. Y-intercepts. The y-intercept here is crossing the y-axis at -3, so that's it. Your problem should have a single y-intercept every single time. The x-intercepts can vary. You could have 2, like I had here. You could have 1 if the graph just barely touches the edge of the graph. Or you could have 0, actually, if the graph never crosses the axis. Like if it's too high, it'll never cross. So there's options. For the x-intercepts, there's options. It could be 0, 1, or 2 different answers. The y-intercept is always one answer. If you have more than one answer for the y-intercept, something's up. Okay, it says find the coordinates of the vertex. -2, -4. If I recall correctly, I did these problems in the past. The order in which you get your questions might vary from mine, and you probably, if you're doing your problems the exact same time you're watching this video, you're probably like, hey, these don't line up. So yeah, that's going to happen. My advice to you is please do it in the following order if possible. I know I did mine in just the order it said, but I think the easiest way to do it is first do the vertex, because you can just identify it from the graph. Then write your axis of symmetry, because the axis of symmetry is related to the vertex. Then write the intercepts in the upward or downward, in whatever order you want. I'd just save those for last, I guess. The order doesn't really matter, but I would say do the vertex before you do the axis of symmetry, because you could just look at the vertex and be like, oh, -2, x equals -2. And then you'll be all good about it. Okay, we'll see another one of those again. All right, the next one says domain and range. So here's a graph. It says the vertex is at 4, -3. That is helpful information for us. So here we go. So the domain refers to how far left and right the graph goes. Notice the arrows are going down, but they are still going left a little bit and right a little bit, and they'll do that forever. In fact, if you watch the lesson video, you were told that the domain for 95% or whatever of the things we do is all real numbers. So for the domain here, all real numbers. There's very few exceptions in Algebra 1 where you're going to see a domain that's not all real numbers, where it doesn't go left and right forever. Here's an example on Desmos. Square root of x. You'll notice this graph does not go left forever. It stops right here and never goes any further. But for most things, the graph goes, even if it's going up or down, it'll still travel a little bit to the side. Okay, so this one actually doesn't go left forever, nor does it go down forever. It stops right here and it only goes up and right. Those are the only directions it goes, which is a very weird thing, but we see it sometimes. All right, back to the problem. The range. So the range is how low and how high the graph goes. For example, this graph goes down forever. It does not go any higher than this vertex point here, which is very important. So you have two options when it comes to the range. So I'm going to write this down, and if you want to take note, take note. So the range is either going to be y is less than or equal to, or y is greater than or equal to. Oops, don't write 0. It's not always going to be 0. So these are your two things. You'll notice I'm using the equal sign. That's very important. There's specific times, and depending on the type of function, where you would not use an equal sign. But in this one, y is always going to be less than or equal to or greater than or equal to, and it'll include the equal to because the line is passing through whatever the highest or lowest point is. Now, the way you choose which one of these you're going to use depends on the shape of your graph. So for this case, for y greater than, that would be a graph that's opening upward. And for y less than, that would be a graph that's opening downward. So in our case, we have a downwards graph. So we're going to use y is less than or equal to. Okay. And then what is it less than or equal to? Well, that's how high does it go? You can look at this, what do you call it, coordinate grid here to see the height, but I would recommend this. Check out this vertex. See how it says vertex at 4, -3? Well, -3 is the y value, and -3 is the height on the graph. I think it's easier just to look at the vertex, because what if this was really like 2.8? Okay, don't rely on a visual for that. Use it. If they tell you the vertex, use it to help you determine the range. Okay, that was a lot of explaining. So long story short, domain, all real numbers, every time on parabola graphs. Range, Could be less than, could be greater than, depends on the shape. And then the thing you'll put less than or greater than depends on what the y value is. Okay, how are those 4 problems? If you thought those 4 problems were manageable, you'll be happy to hear that the next 4 problems are just the same thing, with some minor adjustments. Problem 1 and 2 told us to plug in -2, -1, 0, 1, and 2. 5 and 6 tell us to graph, but they don't tell us to plug in specific points. They say graph the vertex and 4 additional points. So if you're going to be legitimate about it, you would have to say to yourself, okay, I need to find out where the vertex is. And how do you find the vertex? Well, that was -b over 2a. That's the x value of the vertex. And then you'd have to plug that back in and find the y value of the vertex. The problem is there's not really b's and a's here, so it's iffy. Where do you say the vertex is? So I'm going to show you the fun way. Not the fun way. A different way, let's call it. You grab your graphing calculator. My best friend Desmos.com is here to save the day, and I type it in and it's graphed. Now the problem for you is, how do I convert what's graphed on Desmos here into what they want on Alex here? I mean, this is just showing me what we want, but how do we get it here? So the first thing I do is this: find the vertex. The vertex is 0, 0, so that's helpful. That's going to be a point on here anyways. Might as well click it while I'm at it, right? Okay, and you need 4 additional points, 2 on each side of the vertex. So how do you make these appear? Well, this is the gross choice. Please don't do this. You can you can drag it and try and get some whole numbers. Yeah, there you go. -1, 1, -1, right? That's a hassle, right? So here's what you can do. If you're using Desmos, you can click on this little gear up at the top, and there's a button that says convert to a table. Do it again. Gear at the top, convert to table, boom. What that does is it spits out the -2 to 2 and the values, and you can see all the points so nice and neat on the graph here, and those are the points I'm going to put on here. So -1, -1, -2, -4, yada, yada. Boom. Now, could I have done that on the first 2 problems? Of course I could. Could I have done that on any of these problems ever? It's questionable. I'm going to hit check here just so you can confirm that that's right. I do want to show you something that's only true for this assignment, but won't be true for every assignment or everything in the future. Let's say I had y equals 2x squared minus 4x plus 7. Okay, there's a vertex at 1, 5, right? But if I hit the table button, it spits out stuff, just like I said before, but it doesn't spit out 2 on each side of the vertex. It actually puts 3 to the left and 1 to the right, because Desmos by default always uses -2 through 2. If you are not getting enough points to one side, like for example 1, to the right of 1 is 2, but there's nothing for 3. So how do you make it show the point for 3? You go to this table and you type in 3, and it'll add it. You can add as much as you want. You can do 4, 5, 6. You can go backwards too. Well, you want to know what happens when you go -10? -10, whoops, not 0.10, but -10. How to use a keyboard. There's -10. So you can type in anything here and get results. So you just really need to find the 5 values that make sense for your graph. For right now on these problems on part 1, 0 through -2, -1, 0, 1, and 2, those make sense to use. So it'll be very convenient for you, but I'm giving you a fair warning. When you get to a future part, it's not going to be so nice. All right, let's do a next one. So graph the parabola. I'll do the same way. So y equals x squared plus 3. It's graphed. You'll notice the vertex is nicely in the center. Now it's up a little bit. It's not 0, 0, but it still will, if I just convert it directly to a table, it will still show me the 5 points I need. It shows me the middle and then 2 to each side. So let's graph it. -2, 7, -1, 4, 0, 3, 1, 4, 2, 7. Perfect. Now, if you're very mathematically inclined, you will notice that the vertex, the starting point, tends to have the follow-up point go up 1 and over 1 or down 1 and over 1. And then the next point goes up, multiple amount. Like this one, it goes up 3 times and over 1. So there's like a little bit of a scale here. The first 2 away usually tend to go over 1 and up 1. That depends, though, on some values in your function. The a value affects it. In this case, the a value here is 1, so that's why it went up 1 and over 1. So I'm just saying that because, I don't know, I'm just trying to give you some mathematical thought here. The second point should go up 4 and over 2 by default. Okay, we don't know that. That's always the case. Just trying to give you some, I don't know, thinking things. All right, onward to another problem. Just like we saw earlier. So I'll do what I told you guys, and I'll do it in the order I suggested. First, let's identify the vertex. That's not the first question, but let's do it. The vertex is over 4 and up 2. So let's start with that. Okay. The axis of symmetry equation is x equals, please don't forget, x equals every time. That's part of the equation. It's not just a number. Well, what is the x equals? It equals 4 because that's the value from the vertex, right? Again, if it was an equation, you would have to do some negative b over 2a stuff. Or I guess if you wanted to, you could graph it on Desmos and then let Desmos be the guide. Like here, there's no way you could derive the equation, but using my insane mathematical knowledge, I will show you what the equation will look like for you. Oops, with the negative sign right there. There you go. I just graphed the thing that is happening up right there. You wouldn't know how to get that, and that's okay. Maybe in a future lesson I'll help you know how to get that. But I'm just saying, if you have an equation and you graph it, you could use it to help you find the vertex and use that to find the axis of symmetry, I guess, if you had an equation. All right, anyways, back to the problem. Is it open upward or downward? Downward this time. Notice the lines are going down, so that's down. What are the intercepts? This one, again, has two x-intercepts at 2 and 6. That's where it's crossing the x-axis. And the y-intercept is -6, where it's crossing the y-axis. Please, there's a lot of words, definitions, and stuff going on here. Don't get them confused, okay? Vertex is that turning point. Axis of symmetry is imaginary line that cuts this in half. That goes through the x value of the vertex, so those should be related. The x-intercepts cross the x-axis, and the y-intercepts cross the y-axis. Done deal. All right, another one. Domain and range. Okay. Hey, by the way, be careful, Alex. I don't know if this is going to happen on yours. It didn't happen on mine. The domain and range. Sometimes they put range first, then the domain. It's a silly reason to miss a question. I mean, if it's a homework assignment, I could understand, but if you're being tested, you got to be careful. Okay. Domain, all real numbers, right? We talked about that earlier. It's always all real numbers. You don't even need to think about it. The range here is back to my point from earlier. Oh, I erased it. Y is greater than or y is less than? Well, in this case, the graph's going downward, and that was a y is less than situation. And it's less than or equal to, you can look at it visually, or use the point. They told you the vertex goes up to 1, so we'll say 1. Again, the reason why we're saying y is less than or equal to 1 is because if you pick any point that's on this graph, the y value of it will be 1 or something less than 1. Like if I pick this point, the y value is 1. If I pick this point, the y value is now less than 1. If I pick this point, the y value is less than 1. Actually, all these points are less than 1. Dodoy. But if I said y equals 2, which doesn't fit in with this, what do you call it, restriction I've written here, there is no y value at 2. If I go up 2, notice that nowhere in the history of this line ever will it cross 2, right? No y value will ever be 2 or 3 or 4 or any of that stuff. It only ever goes up to 1. So therefore we say the y values are equal to 1 or less. All right, assignment done. I'm going to hit submit, and then as is tradition, I will do a quick review here if you want to help see how it's all wrapped up. So technically we had 8 problems, but they were really 2 sets of 4 problems because there was 1, 2, 3, 4, and then a similar 1, 2, 3, 4, just differently numbered. So problems 1 and 2, 5 and 6 had us graphing. And the way we graphed was, well, on 1 and 2, I showed you how to make a table by plugging in the x values and getting out the y values and then using those to plot the points. On 5 and 6, I showed you how to use Desmos to graph it and then use the points from the Desmos table to just slap it on Alex there. Easy peasy. Problems 3 and 7 were the same in that they had us look at a graph and decide what the different pieces were. So what's the vertex? What's the axis of symmetry? Where are the intercepts? Is it upward or downward? And then on number 4 and 8, we did the domain and range. Domain is all real numbers, and the range is y is less than or greater than. Both of mine were going down, so mine were both less than or equal to. Yours could vary, so be careful. And then we chose a specific value that y was less than or greater than, depending on A, the vertex, or B, the high or low point of the graph. Depends on what you got. All right, that covers video 1. I hope that was helpful for you. If you have questions, please seek out your teacher. I guess if you're watching this, it could be my student or any other teacher-student. So please ask questions, get some help. This isn't the easy stuff. There's a lot of stuff going on here, so please let us know if you need some help, and we'll be here for you. All right, with that, I'm ending the video, and I'll see you next time. Bye.